FastMCP 3 implements dynamic component visibility through version-based filtering, allowing runtime control over tool availability via semantic versioning constraints. This mechanism enables precise access management by selectively exposing components based on version specifications. The upcoming code demonstrates how to configure version-specific tool activation using VersionSpec to filter components, with the system applying these constraints during context initialization. You'll observe the asynchronous enablement process that modifies the component registry according to the specified version criteria. From FastMCP Utilities Versions, import VersionSpec. At MCP, Tool. Async def enable recent tools text, context SDR. Enable only tools from version 2.0.0 or later. Await CTX, enable components. Version equals VersionSpec equals 2, 0, 0. Components equals tool. Return, recent tools enabled. This code demonstrates FastMCP's version-based tool filtering using VersionSpec, a utility for semantic version comparison. The Enable Recent Tools function is a session-level tool that selectively enables only components with version 2.0.0 or higher, specifically targeting tools via the components equals tool parameter. This pattern is useful for progressive feature rollouts or API versioning, where you want to expose newer functionality while maintaining backward compatibility. The implementation leverages FastMCP's visibility system, where CTX, enable components, applies session-specific rules that override global defaults. By using VersionSpec equals 2, 0, 0, it creates a version filter that matches any component with version greater than or equal to 2.0.0. The components parameter optimizes the operation by only affecting tools, which triggers a toolless change notification for the session without unnecessary resource or prompt notifications. This approach provides fine-grained control over component exposure at runtime, enabling scenarios like A/B testing, phased deployments, or role-based access to newer features. The trade-off is increased complexity in managing version components, but it's more efficient than maintaining separate deployments for different API versions. The session-level filtering ensures changes are isolated to individual clients without affecting the global component registry. Let's break it down. From FastMCP Utilities Versions, import VersionSpec. Imports the VersionSpec class from the FastMCP Utilities module, which provides version specification functionality for component versioning in the framework. At MCP, Tool. Async def enable recent tools text, context SDR. Enable only tools from version 2.0.0 or later. Defines an asynchronous function named Enable Recent Tools, decorated with @MCP tool, which registers it as a FastMCP tool. The function takes a context object as input and returns a string. The docstring indicates this tool enables only tools from version 2.0.0 or later, though the implementation logic isn't shown in this segment. The decorator automatically handles tool registration using the function name and docstring for metadata. Await CTX, enable components. Version equals VersionSpec equals 2, 0, 0. Components equals tool. Enables the tool component with version specification requiring at least version 2.0.0. The call awaits completion of the operation, indicating this is in an asynchronous context. The component's parameter explicitly lists tool as the component to enable, while the version parameter uses VersionSpec to enforce the minimum version requirement. Return, recent tools enabled. Returns the string literal, recent tools enabled, as the output of the function. FastMCP3's version-based filtering ties together semantic versioning with runtime component visibility, creating a dynamic access control system. The VersionSpec utility defines version constraints that CTX, enable components, applies during context initialization, while the @MCP tool decorator registers the function as an executable tool. By combining these elements, version specification, component targeting, and session-level filtering, you get isolated, client-specific tool exposure without modifying the global registry. The trade-off is clear: slightly more complex version management in exchange for deployment efficiency and precise feature rollouts. This pattern essentially turns version numbers into access control tokens, letting you expose newer functionality incrementally while maintaining backward compatibility through the same codebase.
The version filter slices at 200, yet the client grabs the newest. Both seek, neither whole.